Hi guys, today we'll be doing a video that I've been meaning to do for a long time, which is doing a comparison of the Fluke 83 original series to the Fluke 83 3 series. And if my camera would ever focus, we could actually see that very clearly. Now this isn't going to be a really huge in-depth kind of review. It's just going to be a little bit of apples to apples comparison of each meter, kind of these more or less surface differences, and we'll talk a little bit about the accuracies. There's not going to pull these apart or anything like that. This is just going to be kind of a little buyer's guide, I guess, of, you know, if you're looking at these meters and you're trying to figure out which one you want or which one might work for what you're trying to do, then hopefully this video will be helpful. Now, the first thing you may notice just right off the bat is the displays. Now, on the 83 3 series, you'll notice this display is much darker. This is not typical of these meters. If you've watched my screen repair video of this actual meter, you know that I've changed the polarizing film, and I just used a kind of off-the-shelf film, and that's what gives that meter this darker appearance. Normally you would have really clear digits like the 83 is showing. However, if you look at the 3 series, you notice that the digits are a little bit bigger, which would make it a little easier to see from a distance. Another feature you might notice right off the bat is that the 83 original series has no backlight function. The 3 series is going to have that backlight. Now, I believe that the original 87 has a backlight. Don't quote me on that, but just it's something that when they did this 3 series meter, they put a backlight on it. Those of you that are familiar with the 5 series of the 80 series of multimeters may also notice something, and that's going to be that on your current readings, Fluke still was going with the what I call DC default. That means that whenever you spin it around to the amps reading, it's going to automatically be on DC, and if you're doing any AC current readings, you have to actually pick your function button to switch out to that. I prefer this for electronics work because you will do a lot of DC current readings. There may be some people out there that prefer the AC current readings, but that's just one thing about the 87.5 and really any 5 series that kind of I'm not really a fan of. I really like these DC default current readings. In fact, most of the time whenever I'm going to be measuring current, I'll actually grab my 3 series to do that with. Other than that, functionality is pretty much going to be the same, just surface wise. I mean, you still have all the same readings. You've got your volts AC, volts DC, millivolts DC. You've got your ohms, your buzzer, continuity buzzer. You've got diode check. You've got capacitance. You've got milliamps, amps, microamps. You know, just pretty much the standard 80 series type of functionality. Alright, we're getting to the point where we're going to really see the internal difference in these 2 meters, and that's going to be through accuracy. If you look at the original series, and if you can bear with me for just a second while I scroll through the specs so I don't get them wrong. If you look at the original series 83, DC volts accuracy is rated at 0.3% plus 1 count. If we look at the 3 series, then DC accuracy is going to be 0.1% plus 1 count. So you get a much more accurate meter in the 3 series meter. Now you may actually notice I am putting about 10 volts into these meters from the same power supply, and there's a slight difference in it. I wouldn't say that that's actually because the 83 original is less accurate. That may just be kind of a calibration difference in there, but the reality of it is that the original series is going to be a little less accurate. So if you ever find yourself trying to choose between these two meters, that is really the main thing that I believe that I would keep in mind, is if you need that higher accuracy, then the 3 series is going to be the one that has it. Just to kind of stay in the same vein of the accuracy on these meters, if you're looking for really high accuracy, the 85 series are typically going to be almost what you would want, depending. If you need super high accuracy, of course the 87 is always going to be the best, but generally, just looking at the surface accuracy, the 85 and the 87 are comparable. The 87 has a few more features, and also there is a little bit of an accuracy difference in them. It's actually a footnote if you kind of scroll through the specs here. Where is it at? Yes, for the 85 series, the 85 series is actually a true RMS meter. However, when reading in milliamps and amps AC, so your current readings on your AC side, it's actually going to be less accurate below a reading of 200 counts. Yeah, below a reading of 200 counts, add 10 counts. But since we're not really talking so much about the 85 series and the 87 series, that's not something we're going to worry about in this video. Now, if somebody were to, I don't know, say donate a 85 series meter to me, I'd be more than happy to talk about it. Just to kind of go back to the surface differences of this meter, of these meters, or rather the lack of, the actual cases, both the shell and the rubber holster cases, are identical for the 3 series, the original series, and even the 5 series. So if you're looking for replacement holsters for these, you can always get a regular, the newer 5 series holsters, and they'll work just fine, and they'll actually make the meter look like it's a 5 series meter if you're into that kind of stuff. I don't really care. I actually kind of like these original holsters a little bit better. I find that they're just a little bit less bulky, but the newer cases do offer more protection, and the tilting bail I find is a little bit more friendly to work with. I really don't think that it'll be fun to just scroll through and read all of the specs on these meters, so let's play with them a little bit. As you can see, DC voltage, they're both pretty close to each other. I mean, they agree fairly well. If I just crank my power supply up to as much as it can go, we can see that they still hang in pretty tight with each other. Also, another thing that can be creating a little bit of a difference is that whenever you connect meters like this in parallel, there could be a difference. I mean, look, even just moving the leads like that kind of creates a bounce. And my power supply is actually bouncing a little bit because it is wicked all the way up. We can back off a little bit to try to stabilize that voltage some. But as you can see, they stay fairly close, within least significant digit, which is going to be acceptable for most people. So I thought I would play around with the meters and show a little bit of the measurements and stuff. But I noticed something kind of strange that happens on the original series meter whenever you're trying to read frequencies. I've got a 60 hertz sine wave that I'm going to inject into the meters here to try to measure. And if we look at the 83 series and the 80, if we look at the 3 series and the 83 at the same time, you'll notice something kind of strange here. There's no inputs at all on the original series, and on the 3 series it's showing that 60 Hertz 59.99, but the 83 is matching that. So that's really strange. And we can swap them around here, and you'll see that the 3 series goes to 0 and the original actually reads the 59.99. So let's try to adjust that frequency sum and see what's happening here. That's 90, so it is reading accurately. Let's check the data sheet and see on frequency where we can get up to here. It looks like the original series can go up to 200 kilohertz. Alright, 199.99. So let's try that. Let's just bring this up to 99. Sorry if my camera is shaking a little bit. It's mounted in the same place as my function generator. It doesn't appear to like that either. But as you can see, the original series went straight back to that 60 Hertz. Could it be picking up like common mode noise or something? It's really odd. Yeah, if we kind of take it away from the filming area here, we go right back down to 0 Hertz. And if we put it, if we put it by some mains lines, we get 60 Hertz. So apparently the 83 is going to pick up external noise a lot more than the 3 series. Just for the sake of saying we did, look, the 87 is doing the same thing. What could be causing that? Let's try unplugging something. No. Well, it looks like it stopped, but there it is again. I do have a wireless keyboard. Let's turn the wireless keyboard off. So there must be some sort of common mode noise happening in here. Stand by, please. No, it's still there. So it wasn't the watch. It's very odd. Anybody who can explain this is more than welcome to explain it, because I'm at a loss right now. Here's something really interesting. I've taken the leads out of my function generator, and I just have the little BNC adapter to banana plug jack. One just like this, except it actually doesn't have the these little lugs on it. So that's the only thing plugged in right now. And if I touch the meters, nothing happens. But watch if I touch the original series meter, and I'm just gonna come right here and I'm gonna grab the ground or the outside of that BNC adapter. We get that 60 Hertz. And I take my hand away and we lose it. Let's try with this one. Yeah, even the channel that's off, the second channel is completely off with nothing on it, and it's still giving me that 60 Hertz reading. So it has to be picking up external noise. Let's try that with the, look, even if I just put my hand close to it. But the 3 series seems pretty immune to that. Let's just try it. Yeah. So that's really weird. The 5 series, the 87 of the 5 series, which is supposed to be one of the greatest, Fluke apparently wrote the Bible on meters whenever they created this thing. It's apparently susceptible to some common mode noise. Anyone who knows the depth of this is more than welcome. Please go in the comments and tell me. If I'm wrong about that, please correct me so that I can not look like a total idiot. But that's just a very weird thing, that the 3 series meter is going to be immune to it, while the original series and a 5 series meter are not going to be. For those of you who are wondering, I am aware of EV blog Dave having done 2 entire videos on Fluke, specifically the 87.5, having high susceptibility to GSM on the older models of it. I feel like that may be something kind of related to what we saw on the frequency measurements on these meters, but to me the GSM, I mean, he was looking at cell phone frequencies. We're talking about 60 hertz here, and it's picking up the 60 hertz through the original and through the actual 87.5. Now, I do believe that I have an older 87.5 that does not have the firmware update that is somehow that's what fixes it, but it's still, it seems like it may be slightly related to me, but also it seems really strange. Alright, I know we kind of got off the beaten path with that frequency measurement little phenomenon that was happening there. So let's get back to just kind of measuring a few things on these meters, just to see if there's any difference, between auto-ranging and things like that. And we've got a few things. We've got this little voltage standard here, and we've got a red LED, so we'll do the red LED test. Just your standard little diode. We got a capacitor here, and we've got a really large 1 ohm resistor, and also a bunch of quarter watt resistors. Don't worry, we're not gonna test all of these. We'll just find kind of a mid-range and a higher range, like a 680K here, just to really try to put that auto-ranging to test, to see if we can tell if there's a really big difference between either one or not. Well, what better way to get started with doing tests on these meters than to do the famous flying probe test? If you watch any of EV blog stuff, then you'll see that this is a really classic test that he loves to do with any meter, really. But Fluke are famous for their latching continuity and that really quick glitch capture, so that even if it's only a very quick little swipe, you're still going to hear not just that it'll actually beep, but a very clear latched beep. So this is going to be the 3 series here, and I mean, it's just, even if you just barely, just the weight of the probes will let you catch that. That's very nice. And here, I think you'll notice something. Those of you with really good ears, listen carefully to the original series compared to the 3 series. It's the same really quick capture, the latching noise, but if you listen to the buzzers, let's go back to the 3 series, you'll notice that the buzzers sound just a little bit different. The 3 series I find is just a little bit subtler of a sound, where the original, not to say that it's louder, but it's a little bit more of a piercing, a little bit different pitch. but both very, very good, very quick. And this is just using the standard, I believe these are TP75 or something like that. It's the probes that you'll normally get with just about any Fluke meter that you... Alright, let's move on to a resistance test. This is a 1 ohm resistor. I think it's 100 watt, if I'm not mistaken. But I've actually measured this on the Keithley 192, and it measures at 0.982 ohms. So we're looking for something just under an ohm. Can we see it in the screen? 1.3. Oh. We have to remember that these meters have a relative function on it. So we need to get rid of that probe resistance. .8, 0.9, up to 1. Is not bad at all. I mean, considering that this is kind of at the bottom of what this thing can measure. Let's see if we can possibly range up to see a little bit more. That's kilo ohms. No, we can't. The reading has changed now because whenever you range into the whenever you manual range these meters, it will actually remove that rail function, which is something that I don't really like. Okay, let's move on to the original. Oh, to get out of buzzer mode there, we will rail out the probes and let's give it a shot. Exactly 1 ohm. So it's actually reading very, very well. Okay, let's give the 3 series a try. Wow, no problems there and the exact same reading. And just for the sake of it, let's just short the probes and see if it sends it through the auto ranging any quicker or slower. We're going to do the 3 series first here. Wow, really, really quickly. And let's do the same thing for the original. Wow, it seems like that's just as quick. At least to my untrained, unprofessional eye. Okay, so I've done a little bit of research. I've dug through the specs on these things, and it looks like, excuse me, at least for the original series, it can only test 5 microfarads. I mean, that's pretty, that's a very small amount of capacitance. Okay, so I've dug through my components and I found a 4.7 mic. Let's give that a try. 4.62. Looks like it got there fairly quick. Let's try that again. And here we go. Pretty repeatable too. Very good. Let's give the 87 a try. Let's discharge the capacitor. And let's go for this again. .63. Extremely agreeable with the 3 series, and it looks like it's just as quick. Okay, so I think we should move right along with the LED test. And we're just going to do a red LED here. Okay, so I've got the red LED hooked on to the 83.3 series. Let's see what it does. I don't know if you can tell. It is lighting it, and it is showing us a 1.569 voltage drop, which is very good. Let's go ahead and switch the probes around here. And it's showing open lead just like it should, or overload, depending on who you ask. Everybody seems to have a different thought on what that means. Okay, let's try the original. Let's see if we're getting a light. Really hard to tell if it's the same as the 3 series, but it is lighting, and it is giving us the exact same voltage drop. Okay, and reverse bias, showing us open leads. Okay, let's try it with a nice diode. Looks like in reverse bias, the original is gonna still stick to its original answer. And it's showing us 0.473 voltage drop in forward bias, which is what you would expect with a good diode. Let's swap that over to the 3 series. .466, it's neck and neck with the original. And a reverse bias on that reveals open lead. Very good. Let's try a direct short. Straight zeros. And straight zeros. Very good. Okay, so I've had the voltage reference warming up for a few minutes. That's just going to help stabilize the voltage a little bit. I realize that this is not a voltage standard, so we're not going to be looking for dead accurate measurements here. Like for instance, this 2.5 volts that we're set to right now, that is actually going to be, on the meter we'll see 2.50, but in reality, if you were looking at this through a big 6.5 digit, you would be looking at 2.5008 or something very, very close to that. Alright, we've plugged it into the 83.3 series, and it's very, very close. 2.498. I wouldn't expect it to be much closer than that. It is, after all, just the least significant digit on the meter. And the 83 original series agrees just fine with it. Let's bump this up to the 5 volt. And that is dead on, and that is actually a little bit high. We're looking for 4.99981 is supposed to be the absolute value of this. But that is absolutely acceptable. And once again, the 3 series agrees with it. 7.5 volts, no problem. No problem. And 10 volts, right at 10 volts. A little bit lower on the 3 series, but that is still no problem at all. We're looking for a dead on 10 volts, but least significant digit, I'm perfectly fine with that. Alright, so let's try out AC voltage. We're just going to measure the mains here. $121.7. Okay, let's try that with the original. 122.1. A little bit higher, but still perfectly acceptable. And one thing to note about these is neither of these are true RMS reading meters. Let's check the microamps range. I'm going to use the 705 loop calibrator here. This is a constant current source. I'm also powering it from my power supply because all of my 9-volt batteries are busy right now. Okay, they took a little bit of juggling, but we do have it all set up now. And we can see 3.996. The loop calibrator is such a rock solid little current source that I know that this 4.000 milliamps is going to be dead accurate. And as we can see, we are looking at 3,996 microamps, which is going to be exactly what we're looking for. And as you can see, it's matching on the original series down to the least significant digit. That's very impressive. Let's go ahead and move up to the milliamps. Okay, we're bouncing right between 3.99 and 4, so I mean that's just excellent. And the 83.3 is reading a little, just the tiniest bit high on there, but that is once again great. Okay, so let's give the amps mode a try. I've got my power supply hooked onto my 100 watt 1 ohm current source. So we're going to end up going into current limiting on the power supply, but I have it set to about 1.5 amps. So we'll just see how close we are on that. And it's actually still staying in the milliamps range. We can probably bring that up to amps. There we go. And 1.6 amps. My power supply is actually reading 1.61, which is in perfect agreement. Let's go ahead and move on to the 83 original series. It's also extremely close to where we're looking for. I mean, they agree with each other so well. That's just mind-blowing. I haven't done anything calibration-wise to these meters, and I mean they're old. They're very old meters, but I mean just the reliability of these things is mind-blowing. Okay, we're gonna step up to one of these 680K resistors to see if we can get that auto range to think a little bit. Let's see here. Make sure that we are in auto. Yes. And here we go. Wow, that was very, very quick. It seems like it just went right. We're looking at 660 678 kilo ohms, or 0.67 mega ohms, which is extremely close. And it got there very, very quickly. That was very impressive. Okay, so while we've got the power supply and everything out, we might as well go to the millivolts range and see how they do. I have the power supply set to 0.35, but it's not very accurate, so let's see where we will be at. Measure across this resistor here. We're at 0.292, which I suspect will be pretty dead on. Let's just get the Bryman out here. .292, exactly what we were looking for. Now that is one thing to say about both of these meters, is that the millivolts range is only going to go up to 400 millivolts, which is not a bad thing at all. It's just kind of, you know, it's reality. Some people may expect it to be higher than modern meters. It is, but in these older Flukes, 400 millivolts, you know, I guess they never expect you to go above that, and if you did, you would range up to your just volts DC, and you could always auto range from there, kind of wherever you needed to be. But that's just kind of how it is on these, and nothing really wrong with it. It's just something to keep in mind. Well guys, I'm sorry if this video kind of took a strange turn, but that was a really interesting phenomenon that was going on there. But I hope that you got a little bit of information on the 83 meters, and if you were to ever have a choice, you know, maybe you'll be a little bit more informed as to which one you would prefer, or which one might be better for you to try to look for. Honestly, I love the 3 series. This is a fantastic meter, and especially now that I know that apparently it does not mind having common mode noise around it, I trust this meter even more now. I do think though that we will look a little bit deeper into what's going on, maybe not necessarily with why these meters are so susceptible to that common mode noise, but and it may not even be common mode noise. There may be some other term that I just don't realize. But I definitely want to look at this signal generator and see what's going on. So be looking forward to that video. Thanks for watching guys, and I'll see you next time.